welcome to today's FDTD GOES Applications webinar. We're very pleased to have Joe Moore, who's a meteorologist in the Duluth Forecast Office, to talk about the Duluth response to last year's Superior, Wisconsin Husky refinery explosion. Go to the next slide, please. This is part of an ongoing series of webinars. If you have a topic that relates to GOES 16 or 17 or to JPSS and you want to give a presentation, please let me know, scott.lindstrom@noaa.gov or Dan Bykos at dan.bykos@noaa.gov, and we'll set you up. We'll try to make it as easy as possible for you to do this. Go to the next slide. Just some reminders. You'll hear about 20 minutes from the speaker. If you have questions, you can send them to GoToChat. Don't press hold. And when you're not speaking, please press mute. That's all I have to say. Take it away, Joe.
All right. Thank you very much. And we will get started here. I'm going to start off with just a map. For those of you not familiar with where Duluth is, we are on the western tip of Lake Superior. Particularly, we call this area the Twin Ports because of the towns of Duluth, Minnesota, and Superior, Wisconsin. The incident happened in the town of Superior. Our office, as the name implies, is located in Duluth. And I have a population density map here. Basically, the darker shades of purple show where the population is. As you might expect with a coastal city, a lot of our population is located right along the water. And so these towns, while they're obviously different towns in different states, they're kind of very closely related. And I'll kind of talk about the impacts of why that's important later on in the presentation. I'm going to start off with a timeline, and then we'll kind of get to some of the details of how this event unfolded and kind of lessons learned. So this event happened on a very quiet weather day. We had a cold front that went through in the morning hours. Otherwise, kind of partly sunny, chances of rain showers, really not much going on. Some breezy northwest winds behind the cold front, but it was a quiet weather day, and that's kind of what we came in expecting in the morning. So in the office, I'm going to show a couple of slides like this where I kind of show who was working and what they were doing. We had 3 forecasters in the office and our observation program leader. 2 of the forecasters were working short and long-term shifts. We had one of our forecasters basically in on an X shift, what we call a supernumerary shift, basically just in doing some training and research. And then our observation program leader was doing the public service desk. All 3 of our managers that have meteorology degrees were also in the office. So there are about 7 meteorologists around to help out with anything that was going on. And then this happened. This was the Husky Energy Refinery in Superior, Wisconsin, where we heard news of an explosion that happened. At 10:06 is when the explosion happened. At 10:20, we got our first notification. I got the notification on a local news station's app, and then shortly after that, we started seeing it on social media. And by 10:30 a.m., once we figured out what was going on, we made calls to the county dispatch, this is Douglas County, Wisconsin, and talked to the emergency manager to offer forecast information. 10:50, we were able to issue our first spot, so less than an hour after this event occurred, we got a forecast out for them. We called the emergency manager to confirm that they received the spot. We offered to do any plume modeling with HYSPLIT, but they declined, but we started kind of running the HYSPLIT runs anyway to see if there was a plume of smoke or chemicals, where it might go. And this is kind of what the picture looked like. All these photos that I'm going to show are from our local newspaper, Bob King. He's an excellent, recently retired photographer that works at our local paper. And so this is what it looked like. 11 o'clock in the morning, they had a press conference. The fire is out. There was a small fire. That little that flame that I got a yellow arrow pointing to, that's just a normal gas flare as part of the refinery process. They said the fire was out, but we obviously see a lot of white steam coming up, smoke or steam. And what was actually happening, we didn't get this photo in real time, but what was actually happening is the explosion had caused large metal shards to fly out from where the explosion had happened. And one of those metal shards had gone into a tank of liquid asphalt, which is stored at a very hot temperature. and you can see that black asphalt shooting out of the tank. So we've kind of given our forecast. We were kind of enhanced in terms of how busy we were in our office. The person who had been doing the short-term forecast, the lead forecaster, basically focused on getting the forecast to the emergency manager and anyone else that needed it. Our Sue stepped out into operations to kind of just make sure everything was being handled, make sure that we weren't being overwhelmed with the amount of duties. I was the other forecaster. I'm basically monitoring information, and our public service desk is kind of taking in all of the incoming calls and directing them. At 12:15, something dramatic happens. At 12:15, that liquid asphalt catches fire, and a new, very large black plume of smoke appears. Before this, by the time we got to noon, about 2 hours after the incident, we'd kind of calmed down. We're on edge a little bit to see if anything else might happen, but it was kind of like, okay, guess there's just an explosion. Looks like things are status quo. But when we saw this happen on the local media coverage, we kind of knew this was going to be a much different day than we anticipated in the morning. Things got busy fast. This is the view from GOES 16, and this is the 5-minute, just the normal CONUS data. On the left is the visible red band. On the right is the channel 3, the veggie band. And it's a little difficult to see the first few times, but especially on the veggie band, you can see the dark, and I don't know if my mouse is going to show on the webinar, but you can see there's a very dark plume of smoke that comes out of where that refinery was, or where the refinery is, and really goes down across parts of northwest Wisconsin, down a few county lines. So we started to see the smoke immediately on radar and satellite. We switched our radar mode into VCP 212 and a sales cut, which basically gave us a low-level radar scan every 2.5 minutes, so we can kind of track the smoke. We're also kind of going through an iterative duty reassignment, so we're trying to figure out who's doing what else needs to be done at this point. By 12:56, we realized the HYSPLIT run will probably be necessary, and so we just sent that to the emergency manager without asking. We figured they might want to know where the plume might go. Initial evacuation was ordered, and we requested a GOES 16 mesoscale sector. I was the one that kind of thought of this and just requested it because I thought, well, it's a quiet weather day. I don't think there was much else going on in the country this day. This is late April last year. And we said, it'd be excellent to be able to track where that smoke is going to see how the HYSPLIT model is performing, and to have that higher temporal resolution to watch it. The mesoscale request did take some amount of time to actually come in. It took about 30 minutes after the request was called in to actually have the data start flowing into us, into our AWIP system. This is what we ended up seeing. This is a clip of the mesoscale sector data, and you can see it's obviously you can see a lot more kind of delineation in how the plume was kind of evolving in that northwest wind. One of the challenges we had with HYSPLIT was that it was not really doing a great job, depending on the weather model you chose, of modeling the plume of smoke. We actually found the RAP was taking the plume of smoke due east, but the NAM-NEST was doing a much better job in the low-level winds of taking this plume the way we were seeing it being modeled to the south. After the fire reignites, we get very busy. I kind of take on a role as a public information officer. Our Sue takes on a role as basically the incident commander, watching the way things are going on. Our MIC, the boss in the office, comes out to help out with the routine products, and the person who had previously been in for kind of a training shift took over the rest of the forecast duties. This kind of allowed our lead forecaster that I have there on the top left, basically to provide all of the decision support services. Any officials that called in from either state, county, state level, federal level, they talked to her so that we were giving a consistent forecast. And then when we got media calls, I kind of handled those. And this was kind of as busy as things got. There was a civil emergency message sent out for an evacuation, and we posted an initial social media post. We used the radar plume to kind of show a shape of where that smoke was going. So obviously as that smoke got farther away, one, it's getting more diffuse. Two, it's getting, the smoke is remaining at a low level, but the radar beam is continuing to go at a higher angle because of how radar works. And so we knew that it really wasn't a good shape of where the smoke was, nor was it actually really where the evacuation zone was. They didn't give us street references or a map of where the evacuation zone was, and so there was a little bit of confusion about where the evacuation method was. And I won't go into all that, but there was a lot of confusion about where the evacuation zone was. By 1:30, a ham radio operator arrived into our office to be able to communicate with the incident command for this fire in Douglas County. By 2 o'clock, we asked Douglas County if they would like to have someone there physically, if they want someone on site. They say yes, and our meteorologist, our warning coordination meteorologist, our WCM, prepared to deploy. By 2:30, she arrived, and also around this time, we start to hear, we knew that they ordered an evacuation, but we didn't know in real time that it was more because of the storage of hydrogen fluoride at the site, hydrofluoric acid, at the refinery site. That was not leaking yet, or there was no concern about this, but the incident command certainly had a serious concern about that. That was part of the reason we asked Minneapolis to prepare for a backup and asked them to basically spin up a backup service, just in case, one, if we had too much going on that we needed our staff to more directly respond to the incident, if they could take over our routine duties, our aviation forecast and that sort of thing. But two, if there was an evacuation ordered of Duluth and we needed to get out of town, we needed to make sure that we could still provide service. At 3 o'clock, our WCM arrived at the Douglas County EOC. So at this point, we kind of have everybody that was working this day is working this event. Our WCM had arrived on site, and that's why I have that red box on the bottom right. Everyone is kind of working this event in some sort of fashion, and we also have a volunteer ham radio operator who's helping us communicate with the incident command in Douglas County. And this is kind of a picture of what our operations look like at this point. From left to right, we've got our ham radio desk volunteer, Steve, who was our public service forecaster at the time, public service unit. In the back is our DSS forecaster. Our lead forecaster was Linda. I'm there in the front and center. We're basically monitoring all the information coming in and responding to some media inquiries we were getting. Our Sue, who took the photo, would have been right up there in the front on the right. And then on the far right there, our meteorologist in charge is kind of hidden back in the corner. That's one of our other forecasters sitting down, and then the evening shift forecaster is arriving. Our TV stations went basically nonstop with this, wall-to-wall coverage, no commercials since the beginning. And there was definitely concern with us. As breaking news situations like this happen, people tend to fill the air with talking, even when there's no new information. We were particularly concerned that the meteorologist on the station might just start talking about, well, what might happen with the smoke, and how is it going to move, and, is the smoke toxic, and that sort of thing. So I was able to organize a very quick webinar for them. Most could not actually speak because they were broadcasting live in the studio, but a lot of them, because they had called in an extra weather person to help out, they were able to watch the webinar, and 3 out of the 4 TV stations were able to be on it, which was excellent. But basically, I kind of showed them the HYSPLIT run. I explained, it does look like as we go into the night, as winds weaken, the cold front kind of moves farther away. We could have the smoke plume go into Duluth, but we're not certain. By 5:15, Duluth Fire Department asked if we could have a weather person at the Duluth Emergency Operations Center on the Minnesota side, and so our lead forecaster to prepare to depart. At this point, things are very busy. We've got 8 people working this event. 2 of them are on site. No one has gone home yet. We did send 1 forecaster home by this point. But otherwise, everyone that was working the day shift is still here in the late evening. This is around 6:30 in the evening. And so we're kind of maybe a little after that, before that. So we're kind of watching everything, but we're also thinking in our minds, how are we going to handle the concerns going into the overnight period? We have a midnight shift coming in, but are some of us going to have to stay and pull an all-nighter to support this event? How is the smoke plume going to change? And I'll talk about the meteorology challenges at the end here. However, we got very lucky. At 6:35, there was a drastic reduction in smoke. This is the before image at about 6:26, and that is the after image at 6:43. And we got to watch this live. We're looking. We're like, wait, where'd it go? By 6:45, there was a press conference that announced the fire was out, and between 7 and 8, we began finally spinning our operations down conservatively. We had heard that the fire was out before. And during this event, we had heard things like asphalt kind of burns like tires, where you can't really put it out. You just have to kind of let it burn, and it might burn for days. And so those thoughts are going through our mind in the evening hours up until they actually do put the fire out. The fire department was able to get in there with some drones, see the smoke, see where the fire was, and safely get in there to apply foam to cut off the fire. This is kind of a little chart of how many people we had working this event and how long they were here. The shading kind of indicates how busy we were, green being less busy, red being kind of the busiest time. But kind of basically at some points in the afternoon we had 8 or 9 people, including the volunteer that we had here, working this event. And for people at our WFO, we're not exactly large offices. We had more than half of our staff are meteorologists in the office working this event. So this is a very high-end event for us. And thankfully it occurred during a day where we had some extra help around. Meteorology Challenges, the big question was, well, what's the smoke going to do as we go into the evening? I showed one of my first slides, I showed how Duluth is just to the west of Superior. If we had winds that were coming off of the lake or slightly more easterly, that smoke could go right into Duluth and right into where a lot of the population is. Because they had ordered an evacuation of a lot of Superior, a lot of the people that had been living in Superior were taking shelter in Duluth. And if they had to then evacuate Duluth, that would be a question of, well, where are all these people going to go? There's not a lot of other suburbs of Duluth that could handle such a large amount of people. Thankfully, the fire was put out, but this is definitely a concern on our minds going into this. HYSPLIT model challenges. It did take 10 to 20 minutes to run. We found the NAMNES was best. The RAP output did not match our expectations. And we really didn't know what we were doing in terms of the hydrofluoric acid release. And so that was a challenge of, well, can we model that? What is that? Should we model that? We also weren't, the company, the way these incidents work is the energy company is going to take the lead in the incident command. And they were not very forthcoming in terms of how much hydrofluoric acid was stored on site, at least to our meteorologist who was on scene. So that was a concern for us, is not being able to provide the service. Here are a number of the HYSPLIT runs that we did. Some of these were done by our office on the NOAA site, on the internal site. Some of them were not done by our staff. They were done by some other offices that were probably watching this event unfold as well. But we did a little over 24 runs of HYSPLIT. And the reason we did so many is basically to see different runs of different models, and as we varied the parameters in HYSPLIT, how it reacted. Some of the lessons learned, I think we did a great job anticipating our partner needs. They talk about us in the after-action review many times. National Weather Service was a large asset to this event. We did a very good job documenting the timeline. Our STU actually started to document pretty early on in this event, just writing down what was going on. Without that, I probably would not be able to have as precise timing in this presentation. But having that documentation is really helpful. Who did we speak to on the phone? Did they call us? Did we call them? What did they want? Where is the incident? Lat lawns. That became an issue. And so having a constant documentation was very helpful for a large incident like this. We did a great job getting the message out. Even though the evacuation message from the county was confusing, we think our reception of it was actually fairly good, and we got a really large reach on our social media, as you might expect. What could have been improved? I had actually personally developed some hazmat training and quick reference information, and we had just not gotten to the point of doing the training for the local office here. So So luckily I was working and I could share that with the staff that was working, but we just didn't have a lot of training on how to handle incidents like this. Being ready for deployment at a moment's notice, we could have done a better job with that. And we also ran into some communication challenges with our deployed meteorologists. Having an internal NWS chat room like a DLH DSS alternative where only employees could access would be a better way to communicate. We don't always know that there's going to be cell phone coverage, and so it's good to have options for communication. And finally, communication with the NOAA Scientific Support Coordinator. This is a position we didn't know about ahead of time, and we've had a call afterwards to kind of learn what they do and how they can support us. And that's all I've got for this. So I'll be happy to take any questions. If you are NOAA, if you work for NOAA, I have a document that has a lot more of the lessons learned. If you see this presentation when it gets uploaded, you can just click on that link. Otherwise, you can send me an email, and I'd be happy to provide you with kind of a lot more details of what we learned about this event. So, thank you.
Thank you very much, Joe. If anybody on the phone has a question, I cannot see if anybody sent questions. Maybe Dan has some there, but just chime in if you have any questions. Don't be shy.
Can you hear me?
Yeah.
Oh, this is Alice Crawford at ARL. Just wondering, so were you running HYSPLIT through the Web Operations Center?
I was running HYSPLIT through the, I'm going to have to click on the link. It's whatever the one we're supposed to use is from the training. I'll tell you what the URL is. Oh, it doesn't work. Okay. We weren't running it on the public site.
Was it with the Cameo Aloha?
Yeah, the HYSPLIT.noaa.gov one.
Yeah, okay.
Yeah, we were surprised that it took like 10 to 20 minutes to run at times because we were doing like 12, 24-hour runs because we didn't know when this event was going to end. Also good to have training on HYSPLIT because the first 2 runs by one of our employees, they were running the HYSPLIT trajectory, not just version model. It's easy to make that mistake when you don't deal with HYSPLIT a lot.
Yeah, did you do the training through the, is it the training through the, forgot what it's called.
The Dispersion Basics, Cameo Aloha, I think it's called, it's HYSPLIT for Emergency Decision Support.
Okay, yeah.
Yeah.
Did you find that training helpful?
Absolutely. Yeah, it's great. Yeah, and so what I had done is I actually had gone through all of that and made this document that I'm showing on the screen now. And this was going to be kind of my cheat sheet for coming up with some local training and kind of distilling that down for everybody, and then doing some exercises locally.
Okay. But and it also sounds like, yeah, if you had HYSPLIT products that were produced from like the SHREF or something, that would automatically combine the different members. That might be useful since you're already doing a lot of different runs.
Yeah, especially in a situation like this. I mean, it was basically we had high pressure building in, and we had an influence from the lake. This is April, so the lake is still pretty cold, and the air temperature would get chilly at night, and so there shouldn't be much wind, but obviously that smoke's got to go somewhere. So that was definitely a concern. And if there was a hydrofluoric acid release, we weren't sure exactly how to model that. And because we don't really understand how the tank would be breached. There's supposed to be a good number of backup methods to make that hydrofluoric acid inert, and how that factors into running a HYSPLIT Cameo run. So that was a challenge for us we don't really know how to handle that.
Yeah. Okay, thank you. It was very, very interesting.
Are there any other questions?
Yeah, hey Scott, it's Brian Mata. Joe, did you think about looking for heat signatures or anything else on the satellite imagery?
Not in real time, no. Mainly because we were so busy just trying to react to it. And this was very unusual, but we had live chopper coverage of this event coming.
Right. Well, that's what makes it so interesting, is to see it from the bottom or the side, and also see it from the top.
Yeah, and a lot of the photos afterwards from helicopters, it was very interesting to watch, to see how it kind of evolved, and how it really dispersed as it went out. So there were a number of concerns downstream. This is in late April, early May. I think people are thinking of planting their gardens, and there was a large, there were certainly some voices saying, well, is it safe to plant my garden now? Based on where all that smoke fell.
Yeah, was there anything precipitating out of that black cloud?
There were a few reports of it, but we didn't really see any widespread journalists reporting anything that actually fell out of the sky. I think most of this kind of just went into the ether because it was just asphalt burning. I don't think ash was a big deal.
Right. Okay.
Yeah, it was certainly interesting. And this picture, by the way, this picture is the view from our office. So.
What about the 1 minute sequences? Did that provide any clues?
To be honest with you, in real time, we weren't really looking at the 1 minute data. The reason that I asked for it is, first and foremost, was just to document it, to make sure that we had full documentation of everything that was going on, and that included, let's get a high-res, let's get a mesoscale sector up here to see how this might evolve. I have not gone through afterwards to actually see if there was a heat signature, but I'm guessing that it showed up pretty well in the 3.9 imagery.
Okay, great. Thanks.
Yeah, we probably would have looked at it more closely if we didn't have other methods to watch it.
Last call for questions.
Yes, just another question about the evacuation. So you were saying that the evacuation was mostly not because of the actual smoke, but because they were concerned about the hydrofluoric acid possibility? Like they were concerned about something happening in the future rather than...
Yeah, they were concerned because after the explosion happened, it flew metal shards everywhere, and by the time they were trying to get on site after the explosion happened to make sure that the hydrofluoric acid tank was intact, but when the smoke started, they kind of evacuated everybody out of there, and so the city and the company that runs this, Husky Energy, runs the refinery, they were both kind of concerned about it, but they also were very shy to talk about what might happen in real time. Afterwards, they kind of talked about that they basically spent their entire day figuring out, well, where do we need to evacuate? What could really happen with this hydrofluoric acid release? But afterwards, they did say, listening to our newspapers podcast, they did a really great in-depth story on this. They basically said, the evacuation zone was all because of a hydrofluoric acid release.
Okay. Yeah, I'm just always curious, because I work on HYSPLIT applications, how they, determine evacuation lanes, and also, if there's anything done afterward to figure out, was the evacuation area appropriate? What kind of products would have helped us either make a better one? Was it inappropriate because it was too large, or was it inappropriate because it didn't get people evacuated that should have been evacuated?
Yeah, this I just put up on the screen. On the left there is the graphic they eventually published, showing where the evacuation zone with the kind of middle of the circle is where the refinery fire is. We don't know what they used to come up with that shape. I believe it was whatever. The discussions they did with that were apparently very secret. Their meteorologist that was on site said that kind of every 15 minutes there was a small group that was going into a private room and having these discussions of an evacuation. So they were very, very secret about it.
Okay. Yeah, that makes it difficult to...
Yeah, and it was difficult sharing the message because the message was 3 miles east and west of the refinery, 2 miles to the north, and 10 miles to the south. which is not a square. It's a circle and a square, like with a radius, and it was very confusing why they didn't just say, you know, between this road and this road to communicate the evacuation area. It was a challenge for us.
Hey, Joe, one more question. Did you make use of the Comet module on the HYSPLIT Cameo?
Yes. So I did, and I've gone through that. And I used that to basically take this notes document that was very helpful to have in the heat of the event to be able to look up, wait, what does this term mean? Why would I adjust this term on the model? And so, yeah, I found the HYSPLIT, the Cameo Aloha one, Dispersion Basics, the HYSPLIT for emergency decision, all of those Comet modules were very helpful.
Right. So did you know about the phone option of contacting?
I did, yes.
Okay.
I actually do have that in the notes here. I have, you know, if you need help, you can call this number for assistance. You're talking about Office of Response and Restoration?
Yeah.
Yeah, so I did, and I did not utilize it, and I think we probably could have called to ask about the hydrofluoric acid concern, but we had very little information to go on to begin with, so we really weren't sure what to put in as an input. But yeah, I am aware of it, and whenever we can get around to doing training here on HYSPLIT Aloha Cameo for DSS, that'll definitely be part of the training.
Well, and you mentioned your area coordinator.
Yeah, the NOAA Scientific Support Coordinator.
Right.
Yeah, so we didn't really know that was a person until they called us and they said, "Oh, hey, you know, you guys doing okay?" And so we didn't really understand afterwards. Now we've talked to them, and he actually came out to our Great Lakes Operational Meteorology workshop that we had here a couple of months ago. So I got to meet him in person, but yeah, we didn't really know what the SCC does and what they support. So it was good to learn about them. I did have that in my notes here of who they were, but I didn't really know who they were until we kind of sat down and talked to them, and you know, asking the question, do you give us weather information? Do we give you weather information? And learning kind of their expertise. And their expertise is more in the water, dealing with modeling spills in the water, but they also kind of serve as a liaison to the Coast Guard especially.
Right. Okay, that's great. Yeah, I worked with Alan on the Comet module back in 2015, so it's you know, it's still pretty good and up to date. I'm just wondering if there was anything new that we maybe need to add to that.
No, I found the training to be excellent, and I don't think I had any questions coming away from it. I thought it was really, really well put together. So.
All right, great. Yeah, we spent a lot of time on the chemical access to the chemical dictionary.
Yeah.
So I guess that would be the one thing to look into. Because for HYSPLIT, you know, you think about, you know, the common scenarios are like tankers or train cars derailing or things like that. And this is a little bit different, but it kind of reminds me of there was a large fire at a chemical plant in Kansas City a few years ago, called the Chem Central fire.
Okay.
And it was different but similar. I mean, it was a chemical explosion with a resulting fire with a big plume of precipitating, you know, smoke cloud that lasted for several days. So actually, EPA flew a plane into it.
Oh, wow.
To determine what the chemical composition of the smoke cloud was, and it actually was precipitating out stuff. for lack of a better term. But
pretty amazing.
Yeah, so you could, if it was a more extensive explosion and plume, that is a possibility of something that can happen. But I'm not sure what's online for that. Probably YouTube would have, some good examples for you. Lots of radar imagery, lots of helicopter video, that kind of stuff.
Yeah. Thank you.
Well, I'd like to thank Joe for this talk and the interesting discussion afterwards.